Welcome back to Batch Math. My name is Kayla Phelps, and today we are going to continue to learn about factoring polynomials using the greatest common factor method. We did these two problems in the last video. In this video, we are going to focus on binomials, where we can also factor out a variable. We're going to do the same thing we did above by looking at the numbers, and we're going to factor out the GCF of the numbers first. So in this case, the GCF of our numbers, 4 and 12 is 4. All right, 4 is the biggest number that will evenly divide into 4 and 12. Now for the new part, looking here, you'll see we have variables attached to each of these terms. In this case, the 4 has an n to the 9th power, and the 12 has an n. These are 9 n's being multiplied. This is 1 n being multiplied. How many n's can we pull out of both groups? In other words, how many multiplied n's do they share in common? Well, one of them, or n to the first power, because the max amount of n's that we can divide out of the second term is 1. So that means it forces the max amount of n's we can divide out of both terms is just the 1, or n to the first power, 1 multiplied n. All right, n to the first power is just n. And our GCF altogether is 4n there. That is our entire GCF. So we're going to put that 4n on the outside and divide out the 4n from each term, putting it on the inside of our parentheses. In this case, if we divide 4 out of the first term, that cancels. If we divide n out of the first term, that becomes n to the 9th divided by n to the first. If you will look at my exponent rules videos, that is the quotient rule. If we have like bases being divided, we can subtract their exponents. 9 minus 1 is 8. Moving on, 12 divided by 4 is 3. And n divided by n is 1. And 1 times 3 is 3. And we are done. That is the full factor form of number 3 there. Looking at number 6, we're going to do the same thing. First, we're going to look at the numbers. In this case, we have 5 and we have 4. 5 is what we call a prime number, meaning its only factors are 1 and itself. 4, its factors are 1 and itself and 2. 2 times 2. In this case, we don't share our greatest common factor other than 1. And dividing out 1 there is not going to change anything. So we do not have a greatest common factor of our numbers. But we can go ahead and look at our variables. Both terms do have a variable. You'll remember if there is no exponent being seen, there is technically an invisible one there. In this case, we want to pull out the maximum number of multiplied r's that each term has. We have 1 multiplied r in our first term. We have 4 multiplied r's in our second term. So in this case, the max amount of multiplied r's we can pull out is r to the first power, or just r. When we pull that out to the outside, we will come in here and we will divide r off from each of these terms. We're dividing off that greatest common factor. And then what will remain will go in our parentheses. In this case, our 5 gets written down. R to the first power divided by r to the first power is 1, and 5 times 1 is 5. In this case, we have 4, and we have, again, quotient rule. R to the 4th power divided by r to the invisible 1 there. 4 minus 1 is 3. That is r to the 3rd power. And there you have it. Factoring polynomials using the GCF method. Thank you so much for your time.